Hi, this is Dr. Eddie Morgan at Clovis East High School, ready to help you with your homework tonight. Tonight we'll be working on Math 1 Homework Worksheet 5.3. Remember, every problem on this homework help exactly mirrors the problem on your homework assignment. So if you're having a problem with one particular problem, fast forward to that problem and we'll be able to help you out. Let's get started. Problem 1 is like what we did in Worksheet 5.1. It asks us to determine whether the table or rule represents a linear or exponential. Remember, the biggest difference is linear has a common difference, which means that it increases by a number, the same number all the time, whereas an exponential has a common ratio, which means it's being multiplied. Now, if you'll notice this one here, if I were looking at just the differences, 16 minus 4 is plus 12. But when I move over to the next one, 64 minus 16 is plus 48. And then if I go ahead and look at the difference for the next one, 256 minus 64 is plus 192. So you notice right away, that means this is not linear. If it were linear, it would be like add 12, add 12, add 12. So let's see if it's being multiplied by something. And sure enough, 4 times 4 is 16. And 16 times 4 is 64. And 16 times 4 is 64 times 4 is 256. So when we see that, that implies it is an exponential. So let's just verify that. It should then have a common ratio, meaning the ratio of the two succeeding terms here. So between 1 and 2, 16 divided by 4 is 4. The next two, 64 divided by 16 is 4. And the next one, 256 divided by 64 is 4. So we do have a common ratio. So this is an exponential function. That's our answer. Problem 2, we're looking again to see if it's linear or exponential. Remember, a linear will increase by the same amount, a common difference, or you'll be adding or subtracting something. Whereas an exponential, you either be multiplying or dividing. So let's start with it linear. Just check that out first. And I noticed that I add 5. And then 9 plus 5, add 5, add 5. So that tells me this is a linear. And if it has a linear, that means it has a common difference. So if we look here, the common difference here, 9 minus 4 equals 5, 14 minus 9 equals 5, and 19 minus 14 equals 5. It also has a common rate, which you'll notice here between these two, 9 minus 4 over 2 minus 1 is 5 over 1. And if we move to the next one, 14 minus 9 over 3 minus 2, this is kind of like figuring your slope between these points, is 5. And the last one, 19 minus 14 over 4 minus 3, is also 5 over 1. Because in a linear function, you have a common difference, a common rate, and the rate of change, or the slope, is always the same because it's a straight line. So this is a linear function. Problem 3 asks us to evaluate each function for the given value. So evaluate means I'm going to plug it in. I'm going to put that value in. So we're going to say f of x. So we're going to put in for x, we're going to put in 3. So f of 3, which simply means what's the value of the function when x equals 3, is going to be 5 times 3 to the third power. Now in this case, that's going to be 5, and then 3 to the third means 3 times 3 times 3, notice 3 times. All right? So that's going to be 5 times 3 times 3 is 9, times 3 is 27. So my answer here is going to be 135. By the way, if you're using a scientific calculator, It's time to, this is the one chapter in this in Math 1 that's good to have a scientific calculator. There's a couple ways that you might see this. For example, you might have one, I'll give you one example, A. You might have a key that looks like this. We call that a caret. So if I were doing 3 to the 5th power, I would type in 3 caret 5 equal or enter, and I would get my answer. Another type of calculator looks like this way. It'll have a key that looks like this, x to the y. And again, if I were doing that, it would be the same thing. I would type in 3, and then I would type in this key, and then I would type in 5, and then enter or equal. So that can help you. Here, our problem, this one, 3 to the 3rd, wasn't hard for us to simply do mathematically, calculate. But as they get higher, you're going to find a scientific calculator is helpful. Once again, let's evaluate this. So I want g for y equals w equals minus 2. So g of minus 2 equals 48 times 4 to the minus 2. Well, let's simplify this first. Remember that whenever we have a negative exponent, 4 to the minus 2 doesn't mean 4 times 4 multiplied. It means divided. Or what I do is I take that and I make it the reciprocal and put it down below and make it 4 squared. All right? So this is going to be 48 divided by 16, which is simply 3. Now for problem 5, we're going to do what we did in the last two problems. We're going to do it for several values and then graph it. So when I want to find f to the minus 2, I'm going to put this in for x. So the first one here is 2 to the minus 2. Well, that's going to be 1 over 2 squared, which is going to be 1/4. So if I come out here to minus 2 and I go up to 1/4, it's only going to be about right there. Okay? Second one is going to be 2 to the minus 1. That's going to be 1 over 2 to the 1, which is simply 1/2. So when I go to minus 1 over here, we're going to be halfway. And then for 0, anything to the 0 power is always 1. So 0, 1. And now we get 2 to the 1 power is simply 2. And 2 squared is 4. So over 2 up 4. And then 2 to the 3rd is going to be 8. 2 times 2 times 2 is 8. 3, 4, 5, 6, 7, 8. And if I want to draw the graph then, it's going to be, it'll never cross underneath here, but it's going to come like this, and it's going to move up something like that. And that's your graph. That's an exponential function. Problem 6 says to evaluate the error. A student evaluated the function f of x equals 3 times 4 to the x for x equals minus 1 as shown it right. Correct his error. So let me just start off by doing it as I would doing it and see where we go wrong. Okay. So first of all, I want to find f of minus 1. So I plug in for x minus 1. Now the next thing I notice is that I need to take care of this negative 1. So I make this 3 times 1 over 4 to the 1. And at this point I'm looking over here and looking at what they did, and I notice that he didn't do that. See, if I finish this out, I'm going to end up with 3 over 4 as my answer. But he actually multiplied this. In other words, when he had 3 times 4 to the minus 1, he did multiplication. Then he did the exponent. Okay? But remember PEMDAS. Which comes first? Exponent comes before multiply. So in my case here, the first thing I did here was the exponent. 4 to the minus 1 is 1 over 4. And then I multiplied them together. Okay? So his error was getting PEMDAS wrong. By multiplying these, you have to do the exponent before you do the multiplication. Number 7 is another graphing problem like number 5. We're going to evaluate this function for each of these values in the domain. So let's get started here. I'm going to have 3 times 1/2 to the negative 2 power. Now remember, when you have a negative power, take the reciprocal and then change it positive. So this is 3 times 2 squared. So that's going to be 3 times 4, or 12. So I'm going to go over here to negative 2, and I'm going to come up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's a little bit off my graph here. Second one, 3 times 1/2 to the minus 1. So that's just going to be 3 times 2 to the 1, or 6. So my second one, 1, 2, 3, 4, 5, 6, right there. And then here we have 3 times 1/2 to the 0. Remember, 1/2 to the 0, anything to 0 is 1. So this is just 3 times 1, or 3. By the way, you should start noticing something here. Notice that since we're multiplying by half each time, it's like dividing by 2. So we went 12 divided by 2 is 6 divided by 3. So we expect the next one to be 1.5. So here we have 3 times 1/2 to the 1. So that's 3 over 2, or 1.5. So here we're going to get 1.5, about right there. And then the next one, 3 times 1/2 squared is going to be 3 over 4. 1/2 is 1/4, or 0.75. So now we're down here about here. And then finally, 3 times 1/2 to the cube power is going to be 3 over 8. And 3 over 8, decimal-wise, is 0.375. So it's going to be down about here. So if I want to graph this, I'm going to start up here, and then it's going to come down, and you'll never get to 0, but it looks shaped that way. Notice that because 1/2 is less than 1, I end it with a graph like that. All right. Most of the ones we've seen are things like 2 to the x, and then the graph looks like that. Problem 8 says, given the graph f of x equals 1/2 to the x to the right. In other words, what they're saying is this graph here is f of x. Can you graph g of x where it's the same but you add 3? Well, this is fairly simple. Take any point, like this point here, and add 3. 1, 2, 3. So that's going to be a point. Here, 1, 2, 3. It's going to be about there. Here, 1, 2, 3. Here, about here. And here, 1, 2, 3. And here, 1, 2, about here. In other words, it's going to look something like this. Notice that it's the same thing, but every point just goes up plus 3. And this could be kind of how we'd have to graph g of x. Now, number 9 is just a variation on problem 8. Instead of a graph, they're giving something similar. We start with f of x equals 3 of x, and then we go 3 of x minus 2. Well, if you think about it, if f of x of 3 of x looks something like this, all I got to do this one is I'm going to take every point down 2. Okay? Just like last time we went up, everything goes down 2, and then I'm going to draw my new line down here. So which one of these describes taking the graph and translating it down 2? And the answer is D. Not right 2, left 2, up 2, or down 2. Minus 2 is down 2. If it were plus 2, it would be up 2. 10 asks us to describe the differences between a linear function and an exponential function. There's a couple of ways to do this. Let me just try to do a little table here to show you. I'm going to put linear here and exponential here. You can look at them, first of all, by their rule. Okay? The rule for linear is y equals mx plus b. Notice that x is to the 1 power. On the other hand, an exponential has x in the exponent. So that's a tip-off there. Another thing you would notice the difference of is that in a linear, it has a common difference, meaning that if you have successive numbers, you're adding something to them. Whereas here, you have a common ratio, and often if you're looking at changes between the numbers, they're usually being multiplied by some number. And with a linear function, if you graph it, it looks like a line. On the other hand, with an exponential, it tends to have more of a look like something like this, although it can go the other direction. It's either always increasing or always decreasing. And instead of having a constant rate of change, constant slope, you'll notice that the slope is always changing as it goes along. So those are three common ways to look at it. If you have this up here has to do when you have a table of values. If you get a table of values, you're going to see them go up, like this might be plus 5, plus 5, plus 5, whereas an exponential might be times 5, times 5, times 5. Problem 11 asks us this question. Is y equals negative 2 to the x power an exponential function? Well, the answer to that is no, and the reason is that in the equation y equals a times b to the x, b has to be greater than 0. And here's why. Just consider this function, for example. I'm gonna let this be a function. And I want you to see what happens when f of 0, obviously minus 2 to the 0 is going to be 1, okay? When I go to positive 1 then, negative 2 to the 1 is going to equal negative 2. When I go to 2 though, minus 2 squared, a negative times a negative is going to be a positive, so I'm going to go to positive 4, go to 3, and you end up with negative 2 to the third. Now a negative times a negative is 3 of them. That's going to be negative 8. And you go on to 4, negative 2 to the fourth. An even number will give me 16. Notice the way it goes positive, then negative, then positive, then negative, then positive. That's going to create a graph that, if you look at this as a graph point, at 0 it's 1, then it goes down to minus 2, then it pops up here to 4, and then down to minus 8. And you can see it's just going to be erratic, and that's why we don't ever do this kind of function. There's no way you can draw lines between here to determine what this is. So that's the reason it's not an exponential function. All right, I hope that helped you with your homework. Have a good time.